Hi everyone. As I told in my previous video, in this video I am going to explain how data science algorithms will work. Data science algorithms means I am not going to explain about any single type of algorithms. It may be deep learning algorithm, it may be machine learning algorithm, it may be classification, it may be regression. Whatever the algorithms will work in same manner. As a generalized manner, I am going to explain today. So, data science algorithms, all the algorithms will learn. Algorithms, with the help of algorithms, we have to train the model. We have to build a model. For that, we need some data. With help of previous data, we have to build the model. Means we have to give the training to the missions, so that missions can think from next time onwards. So that, suppose with help of one example, I am going to explain in this. So, suppose we have some data of 10 years. Previous 10 years data we have. The data is regarding the rainfall again. In last video, I have taken that example. So, I want to continue with the same example. Rainfall information. So, temperature is there. Temperature, it may be 25 degrees centigrade, 25 degrees Fahrenheit, or 30, 33, or 40, like that. This is the temperature. And another parameter is humidity. Humidity, it may be 33, 30, 25, sometimes very less, 10. In summer seasons, humidity will not be there. In rainy season, humidity will be there, like that. Based on the temperature and humidity, how much rainfall is happened on that day. So that is rainfall is 2 centimeters or 2.5 centimeters, 4 centimeters sometimes. It may be sometimes 8 centimeters also nowadays happening. This heavy rainfall is going on in single day also 8 centimeters, like that. So here we have 100 records are there. So this is the data is available with us. With the help of this data, what we have to do? We have to train our model. To train our model, we need not to give all the data, because we have to test with the same data. So from that 100 records, suppose there are 100 records, because we have to give some millions of records and thousands of records and millions of records we used to give. With a small data, with 100 records of data, we cannot build the model. But for example, for understanding purpose, I am giving 100 records. So 80% of data, up to 80% of data, 80% of data can be split as a trained data. We have to think as it is a training data. And another 20 records, 20% of data, 20% of rows are this data can be tested with the build model. So we have to build the data, we have to build our model with help of this training data. First we have to give the training data, so that it will understand, system will understand missions. Okay, if the humidity and temperature are this much, rainfall will happen this much. With the help of like that, we have given 80% of data, so that it will understand. After that, what we can do? Even we have all the data is there available here also. Okay, but we won't give this output. These are the inputs. So I am saying as this is x1, this is x2, this is a y. Y is our output. With help of x1 and x2 inputs, we are finding the output. So inputs also have given and outputs also given to understand the system. After that, what we have given? Only these inputs we have provided to the system for the testing purpose. Training is already happened. So testing purpose we have given only these inputs, so that this output will come. Anyhow we have output, but system given this output. So whatever the system given output is indicating as a y hat. It is a predicted data. System is predicted the output. Something like 3 centimeters or 4 centimeters, 5 centimeters or 2.5 centimeters, like that. Rainfall. It is the output we have. But whatever the data is there in our test data, we have this data. It is also available with us. Suppose it is 4, it is 4.5, it is 5, it is 3, like that is there. But what happened after giving this much 80% of data to understand how much accuracy it is given? Is it giving the correct data or not? We have to compare. This is the output, whatever we have in our available with us. This is the system given output. This is the predicted data we are saying. So if we take this predicted data and if we compare with predicted data and actual data, this is actual data, this is predicted data. 1 centimeter of rainfall is different. So that is nothing but y hat minus yi. For each and every column, these differences will be there. So this is, here is 1, here is 0.5, here is 0, here is 0.5 again. These differences are came. But this difference is coming here means our system is not completely learned. If the difference is not there, exactly whatever the data is there in our output, the same data given means our mission, our algorithm is working exactly, accurately. But here what is happening? Some difference is there. So for sure, for each and every algorithm, every time some difference will be come. This whatever the difference is there, this is y hat minus yi. This can be called as a cost function or loss function, whatever the y predicted minus y actual output and predicted output. This difference can be taken, and with the help of this difference, here in each and every single line we have some difference. The total difference we have to take as a cost function. We used to call. Of course, every time we need not to say this is the only formula. Almost same, because it is for linear regression. This is a cost function. 1 by 2n. N means number of records, and the summation of I equal to 1 to n, yi minus y hat whole square. This is a cost function to refer. With the help of whatever the cost function comes, suppose as cost function is given some 1 means 1 is difference. That 1 need to be reduced. Suppose 1 is very less value. If we think it is a 2 centimeters of rainfall, it is differentiating. Means every time there is if the 4 centimeters it is there, but it is showing as a 6 centimeters. Sometimes it is 6 centimeters. Actual data is there. It is showing 8 centimeters. Not exactly, but in each and every record, sometimes 3 difference will be there. Sometimes 0, like that. But overall difference, that is called as a cost function. That is 2 centimeters is there. But 2 centimeters, it is differently. It is saying means our model is not exactly working. So what to do? This 2 need to be reduced. This 2 centimeters, whatever the difference, whatever the cost function is there, that cost function need to be reduced to up to 0. Maximum we have to find. So 0.001, 0.01, 0.0205, like that, it is okay. Based on that, accuracy can be taken. So if the difference is there, then what to do? Again, we have to build the model. Yes, that is nothing but optimization or hyperparameter tuning. After getting once this difference, tuning can be happened. With the help of tuning, this whatever the 0 or whatever the value of the cost function can be reduced with help of optimization and hyperparameter tuning. Those two concepts came into the picture again. So with help of that, what to do? We have to change the parameters. Means input data is same, but whatever the input, whatever the parameters from different algorithms, different parameters can be taken. For classification, different parameters. For regression problem, different parameters will be there. those parameters. Suppose if it is a regression problem, it is a linear regression problem, their flow need to be changed. If it is a decision tree, that tree model need to be changed. Okay, what is the root node? Those things need to be changed. So that is the thing. If it is a classification or regression, cost function will be there that need to be reduced based on the issue. In this way, even it is a artificial neural network, it is a the CNN. Wherever we go, the difference will be there. Train data will be different. Test data we have to divide. Most of the times, this is a 80 and 20% of our data we use it to divide. For 80% of data can be given to training purpose, 20% of data can be given for testing purpose. After that, y hat will come, that is predicted value, and y will come. Y will be there. This is a cost function. Cost function will come. That value need to be reduced with the help of fiber parameter tuning and optimization in different ways. Okay, this is all for all algorithms will work in the same manner. I am going to explain how this cost function will differ, what is the parameters we have to use for each and every single different algorithms. I am going to explain in next video. Thank you.